Okay, in this last video we're going to try to do problems 31 through 35, which is our Bernoulli equations. And the overall Bernoulli equation, let's just write it out real quick here. It's the hardest one probably to remember in fluids. P1 plus 1/2 density velocity 1 squared plus density gravity height 1 would then equal P2 plus 1/2 density V2 squared plus density gravity height 2. And it's not usually this complicated, because what happens is this all could be on the same height, which means that this one and this one then you wouldn't need. So it's simplified down to the rest of the equation. Or the velocity doesn't change, which means then you wouldn't need this one, and you would use this one and this one. So it can simplify down. It depends on if it's on the same height or if it's different velocities. Or if it's on different heights and different velocities, then you got to use this entire thing. Okay, so problem 31, we have an airplane wing with an area, we're going to use that later, 16 square meters. And the air is going over the top faster than it is going underneath it. That's how an air wing works. And it generates then a lift force that makes the pressure more underneath. So it gives us the airspeed. So here we have there's a wing, and the airspeed over the top is 62, and the airspeed underneath is 54. And it says, what is the weight of the the plane? Yeah, what is the weight of the plane? Okay. Yeah, so we're talking about an effective wing surface of the entire airplane, not just, I guess, a wing. So what is the weight of the plane? And the density of air is 1.29 is what they give us. So we're not dealing with different heights here, so we're not going to use these parts. We're going to be using this equation here. We're going to do P1 plus 1/2 density is 1.29 times 62 squared. We'll talk about the pressure on the top of the wing first, and then that should equal P2 plus 1/2 1.29 times 54 squared. And we can take P2 minus P1. And so we'll take P1 over to this side, and we'll take this whole thing over to this side, minus P2 minus P1, and we'll get an answer for that. And that'll be our pressure difference. That'll be our pressure difference. And then the question is what is the weight of the plane? So that's what is the force? So pressure, if you remember, is force over area. So if we can get the pressure difference, and we can take it times the area, then we'll have the force. And if you remember, the area of the effective area of the plane was 16 square meters. So we get a pressure difference here. Take it times 16, and we're going to have the force. That's the weight of the plane in newtons. Okay, that took a long time for the first problem. Okay, next problem, we have a water gun. It's squirting water out like this. There's a distance of 7.3 meters. And it's a height of 0.75 meters. We're dealing with differences in height, not differences in we are dealing with differences in velocity still. So we'd have P1 plus 1/2 PV1 squared equals P2 plus 1/2 density V2 squared. You might think that this does have to do with heights, because we're talking about how far the water falls later, but that's not the case. The gun is up here, the reservoir and the gun and the water coming out of the gun are basically the same height. So we're not really dealing with the height of that. We do need to figure out what the velocities, the differences in the velocities are. So the velocity of the water in the reservoir, it says, is basically 0. So this whole part's going to be 0. But what is the velocity coming out of the gun? we have to figure out what that is. Well, we can do some trajectory physics and work it backwards. We know that the time it takes for something to fall a certain distance is the square root of 2d over 9.81, and the d is 0.75 meters. So you can figure out how much time it took to fall, and once you know how much time it took to fall, we know that velocity equals distance divided by time. And so during that time of fall, it went over 0.73 meters. So we could take 0.73 divided by the time it took to fall, and we'd have our velocity of the water coming out of the gun, which would be the velocity right there. So what I could do is this equation up here, I could do P1 minus P2 would equal 1/2 density V2 squared, and I could figure out what the pressure difference is there, and that would be in pascals, and we got to put that into kPa. So that would be that'd be it. Problem 32, I think, should be good enough. Okay, 33. We have water circulating through an entire system. And so this time we're going to have to do a lot of stuff. So we're going to have P1, because there's velocities and there are heights. So we're going to have P1 plus density, 1/2 density V squared, V1 squared, plus density gravity H1 equals P2 plus 1/2 density V2 squared plus density GH2. Okay. Now, at the beginning, when the water's on the first floor, we're basically saying that's ground zero, so this thing we're going to turn into zero, so we're not going to need that. So the pressure 1 was given to us, 3.4 E5, that's pressure 1, plus 1/2, the density of water is 1,000, times the velocity on the first floor is 2.1, and that'd be squared. That would equal P2, which we're trying to figure out, plus 1/2 density of water is 1,000, times V2 squared, 0.37 squared, plus, I'm going to start over here, density of water is 1,000, times 9.81, times the height 2. When on the on the second floor, it says it's 4 meters higher. So we can put in a 4 meters in for that. And it's kind of big and ugly, but it's pretty easy to solve for P2. You figure out what the pressure is. Okay, good. Number 34. An area of a hole in a ship's hull, is given. There's area in the problem. Located 2 meters beneath the surface of the lake, what volume of water per second leaks into the ship? So volume of water rate, that's Q, is velocity times area. And we were given the area. So really all we need to do is figure out what the velocity is that I could plug in for there. And this is the efflux thing, so velocity equals the square root of 2gh. We were given the height, you put that in there, you figure out your velocity, you throw it in there, you take it times the area of the hole, and you'll have your volume rate. That's easy enough. Okay, last problem. 2 holes. We have 2 holes. Whoops. And actually this hole is, if you think about it, this hole is going to be bigger than this one because the volume rates are the same. And if this one is further down, the velocity of the water coming out of that hole is going to be more. So the area needs to be less so that when I take the velocity times the area, I get the exact same Q, the same volume rate. Hope that makes sense there. So if the volume rates are the same, let's have this be 1 and this be 2. Volume rates are the same. That means the area of hole 1 times the velocity of 1 equals the area of hole 2 times the velocity of 2 coming out of that one. Okay, so the area, these are circles, so it'd be pi r1 squared times v1 equals pi r2 squared times v2. And of course we can just cross off the pi's. And then we can do kind of a ratio. We could do r1 over R2, that whole thing squared, would equal, let's see, oh yeah, okay. What are the velocities? Well, the velocities are the efflux velocities, how far they are below the surface. So I needed to do this a little bit. Okay, so let's just keep going. Let's just do V2 over V1. Now this would be square root of 2g h2 over the square root of 2g h1, and the square root of 2g's would cancel out. And so your R1 over R2 squared would equal the square root of H2 over H1. Okay, it says that the radius of the larger hole, which should be the one on the top, R1, is, larger hole, the radius is, of the smaller hole is 1, okay. Calculate the radius of the larger hole if the radius of the smaller hole is 1 centimeter. So we're going to put in 1 for R2, and then we'll just have R1 squared equals the square root of the heights. Now, it said the center of one of these holes is located twice as far beneath the surface of the water as the other one. So this, if that's 2, then that's 1. So H2 over H1 actually is 2. So, this is getting messy, I'm sorry. Square root of 2 should equal the R1 squared. So I'm going to take the square root of 2, or the fourth root of 2, and I should have then the radius of that hole right there. I believe you need to put it into centimeters maybe. Calculate the radius of the larger hole if the radius of smaller holes in 1 centimeter. Yeah, I think it's supposed to be in centimeters, so you might want to do that there in the end. Okay, hopefully that's enough hints to be able to solve all of those problems.